In this video, we're going to consider how to work out the area under a graph. We're not going to discuss just yet why you would want to do this, just the skill of actually doing it. Let us suppose that we were supposed to find the area under this graph between 0 and 6 on the x-axis. So this whole area here. Now I hope you realise straight away that this is not straightforward because we haven't got a standard shape here. We haven't got a rectangle, triangle, trapezium, something that we know the formula for. It's got curved edges. Okay, we know the formula for the area of a circle, but it's not a circle. So all we can do at the moment is approximate this area, and that's how this method works. What you do is you split up the area under the curve into sections. Now I could split it up into two strips, from 0 to 3 and from 3 to 6. But for the purposes of this example, I'm going to split it up into 6 strips. You'll see later on, I hope, why it's better to have more strips rather than fewer strips. It's more accurate, although it's obviously more work as well. So we split the area that we want to work out up into these equal width strips. And then what we do is we approximate this curve. This is almost a triangle, but not quite. So we approximate it by saying that it is a triangle. This is almost a trapezium. We approximate it by saying that it is a trapezium. And we do that all the way across. Lots of trapeziums being added together effectively. I hope you can see that this trapezium is an overestimate for the area because the curve itself is lower than the red line, whereas this trapezium is an underestimate of the area because this is above the red line. So what we're going to do is we're going to work out each of these 6 areas, add them up, and that will be our approximation for the area under the curve between x equals 0 and x equals 6. Now the area of a trapezium, let's just review that before we go any further. You should know that if you have a trapezium, length A, length B, and a perpendicular height of h, then the area of this trapezium is a half of a plus b multiplied by h. The only thing is, this does not look like these trapezia here. So perhaps it would actually be helpful to redraw our trapezium, put it on its side. Let's make one of the sides horizontal. So effectively I've straightened this line up. And here is A, B, and H. The same formula applies to this because I've put my 2 parallel sides here rather than here. So I'm going to use this to work out the area of each of these trapezia. It might be helpful just to label them so that in my working I can keep track of what I've done. So area A is, well, it could be thought of as a trapezium. It's a funny trapezium. What's happened is that this length A here has collapsed down to just be 0. It's got a height of 0 on that's vertical length there. So I could treat it like that. It's perhaps more straightforward for the moment just to treat it as a triangle. Half times base times height. A half times a base of 1 times a height of approximately 1, I'm going to say 1.6. That works out at 0.8. Area B is a trapezium. And so I've got a half times A. Now, this A for this trapezium is the left-hand side of trapezium B, but it's identical to what was the right-hand side of triangle A. And I estimated that this was 1.6, so I'd better also estimate that that is 1.6. This 1.6 here on the right of the triangle should really match the 1.6 on the left of the trapezium. That is pretty much 5. And times the height, well, let's remember that the height is actually across here. It's the strip width. It's times 1. So 1/2 times 6.6 times 1, that makes 3.3. And I keep going. I work out area C. Let's put it over here. 1/2 bracket A plus B times H, 1/2 bracket area C. I want the left hand side. I've already said that's 5 in the previous calculation. The right hand side of trapezium C, I reckon, is about 7.3, maybe 7.2, let's go with 7.2, times the strip width of 1, 1/2 times 12.2, so an area of 6.1. I'm not talking about units here. There's no centimeters or anything like that mentioned. They're units squared if you want to write something down. That's not really the point just at the moment. Now, it's a little bit laborious, and the potential for going wrong is huge. You've just got to be very careful. For trapezium D, on the left-hand side, well, I've already used 7.2, so I better use that again. Plus the right-hand side of trapezium D, I reckon that's 8, times a strip width of 1. That's 1/2 times 15.2 times 1. That's what, 7.6. Now, this is not as neat and tidy as I would like. It's getting a bit all over the place. But at least the different bits of working all stand on their own and are understandable. 8 for the left-hand side of trapezium E. The right-hand side of trapezium E is slightly more than 6. I think I'll say 6.2. 1/2 times 14.2 times 1. So that's 7.1. And I'm going to have to scroll down a bit. Area F. Final trapezium. The left-hand side of trapezium F, 6.2 plus a bit more than 3.2 times 1, the strip width, 1/2 times 9.4 times 1, so I've got 4.7. The total area equals all of these added together. Area A, if I scroll back up, was 0.8, B 3.3, C 6.1, D 7.6, E 7.1, and F 4.7. Huge potential for going wrong here. Just do it mentally, hopefully accurately. 4.1, 10.1, 10.2, 17.2, 17.8, 24.8, 24.9, 28.9, 29.6. Double underline for a final answer, 29.6. We can actually now judge whether that's actually believable. Let's just imagine for a moment that this had been a nice straightforward rectangle. We know how to work out the area of a rectangle. A base of 6 times a height of 8 would make 48. Half of 48 is 24. Is it believable that this is perhaps about half of the rectangle? Yep, it probably is. 24. An actual answer of 29.6. That's a believable answer for this question. The only other thing to say is that these numbers that I've been using here for the heights of different bars, the A's and B's of the trapezium, they're estimates. And they need to be as good as possible. So you do need to be careful reading off the graph as carefully as you can. But that is how you work out the area under a graph. And in another video, we'll talk about why on earth you would want to do such a thing.